Welcome back to the second part of the Ultimate Next.js series. In part 1, we covered the essential concept to build full-stack applications with Next.js and TypeScript. In this part, we'll take everything you have learned and apply it to a real-world project. We'll build and deploy a full-stack, production-grade issue tracker. This project includes all the common features you find in modern applications: dashboard with charts, filtering, sorting, and pagination, forms with client-side validation, user authentication and access control, modal dialog boxes and toast notifications, and much more. By the end of the course, you will have a fast, responsive, fully functioning application in the cloud that you can share with your friends or potential employers to get your dream job. We'll build this with a cutting-edge tech stack for building modern applications: Next.js, TypeScript, Tailwind, Radix UI, Prisma, and NextJs. I'll break down every line of code so you'll grasp the what's, the why's, and the how's. I will also show you how to structure your projects effectively, how to write clean, professional quality code that aligns with industry standards and best practices, how to use shortcuts to boost your coding speed and overall productivity, and how to think like a software engineer and build software in a structured and methodical way. This course has everything you need to become a professional Next.js developer. So if you follow along, you'll gain the practical skills and knowledge to build real projects with confidence. I'm Mosh, a software engineer with over 20 years of experience, and I've taught millions how to code and become professional software engineers through my YouTube channel and online school, codewithmosh.com. So are you ready to jumpstart your career as a Next.js developer? Then let's jump in and get started. All right, so what exactly do you need to take this course? As I mentioned in the introduction, this course is the second part of my Ultimate Next.js series. So ideally, you should have watched the first part, or at least know the basics of building applications with Next.js and TypeScript. More specifically, you need to know the basics of client and server components, routing, building APIs, database integration with Prisma, and authentication with NextJs. Now, in this course, we'll heavily use Tailwind for styling our application, so you need to know the basics of Tailwind as well. If you're unfamiliar with these topics, I highly recommend you to go back and start from part 1. Otherwise, you might find this course a little bit challenging. Now, I've created a GitHub repository for the project we're going to build in this course. So go to my GitHub account, Mosh-Hamedani, and search for issue tracker. It's right here. In this repository, we have the complete source code for the project we're going to build. And also, there is a separate commit for each lesson. So as you're following the lessons, if something doesn't work, you can go and find that commit. All these commits are named exactly like our lessons. So if something doesn't work, look at that commit to compare your code with mine. Now, before we dive in, let's talk about how to make the most out of this course. There are 2 ways you can take this course. Some students prefer to code along with me, and that's perfectly fine, but I have meticulously edited these videos to take out all the unnecessary, time-consuming segments, so everything is quick and to the point. Otherwise, this 7-hour course would end up being 10 hours or longer. So if you're not a typing ninja, you might need to hit the pause button a few times to keep up. Now here's another way to go about it, and that's my recommendation. I would say, while watching each lesson, don't do any coding. Instead, watch closely, take some quick notes, and then after each lesson, give it a shot on your own. In my opinion, this is a better way to learn because you're not just copying what I do, you're thinking on your own, and that makes the info stick better. A lot of my students ask me, Mosh, I don't know how to start and finish a project. So in this lesson, I'm going to show you a roadmap that helps us plan our projects effectively. This roadmap gives us a clear path and helps us decide what features to build first. So before we get into the specifics, let's classify our features into two categories. essential or core features, and advanced or nice to have features. This classification will help us prioritize and build our issue tracker or any project step by step. So, what are the essential or core features of an issue tracker? I mean, the absolute must-haves. Well, the most fundamental feature is the ability to create an issue, because that's the primary purpose of an issue tracker, to create and tackle issues, right? So we should build that feature first. Once we build that feature, the next step is to allow the user to view details of individual issues so they can better understand the problem. And after that, we want to allow our users to update or delete an issue. Once we build these features, then we can gradually enhance our application by adding more advanced features based on our project's needs. So we'll implement features like user authentication, assigning issues to users, sorting and filtering issues, pagination, and dashboard. Now here's the key. When building this application, we're going to focus on one feature at a time. So we're not going to get distracted with the complexity of the entire project. Also, when building each feature, our goal is not to come up with a perfect solution right away. There's no such thing as perfect in software. Being a perfectionist wastes a lot of your time. You'll spend hours and hours thinking about that perfect solution just to discover that it has flaws. So we want to start coding right away and come up with a working solution. Once we have a working solution, then we'll refine and improve our code step by step. This is called refactoring. Okay, our feature roadmap is set, our journey is clear, so let's set up our development environment and get started. All right, now let's talk about setting up our development environment. In this course, just like my other courses, I'll be using Visual Studio Code or VS Code. You're welcome to use your preferred editor, but if you want to use VS Code, I want you to install these extensions. So head over to Extensions panel and search for ES7. It's this extension right here, ES7 plus React, Redux, and React Native. With this extension, we can quickly generate React components. It's very handy. The next extension we're going to use is TypeScript. It's this one right here, JavaScript and TypeScript nightly. The next one is Tailwind. It's this one right here, Tailwind CSS IntelliSense. This gives us auto-completion when using Tailwind classes. And the last one is Prisma. So Prisma, with this extension, we get syntax highlighting and auto-completion when creating Prisma models. So make sure you have these extensions before moving on to the next lesson. Now, to create our project, open up a terminal window. Now I'm going to go to my desktop. Now, to create a Next.js project, we run npx create next app version 13.4.19. Make sure to use the same version so everything I show you in these videos work the same way on your machine. Let's go ahead. Let's proceed with the installation of this package. Now we should give our project a name. I'm going to call it issue-tracker. And then we'll accept all the default values for these questions. So we're going to use TypeScript as well as ESLint and Tailwind. We're not going to use the source directory. And we're going to use the new app router. And the final question, we don't care about customizing the default import alias. Let's go ahead. Our project is created. So let's cd into this folder, issue tracker, and run npm run dev. All right, our project is hosted at localhost port 3000. Here's what we get, beautiful. Now let's open this project in VS Code. So here in VS Code, first we have to do a little bit of cleanup. So let's go to our app directory and open our home page. We don't care about any of the markup here, so let's simplify things. I'm going to delete all the markup. Where is the end? Right here. And add a simple div. And here we say, hello world. We don't need the import statement on the top either. So here's what we get. Now we have this weird background color because of the gradient applied to our body element. So let's go to VS Code. We're going to go to global.css. In this file, we're going to remove a couple of custom CSS properties. One is background start RGB, and the other is background end RGB. And then here in the body element, we remove the background color. With that, here's what we get. Looks good. And now we make our first commit. So we go to our source control panel and make a commit. And here we say initial commit. Now at this level, I expect you to be familiar with Git and GitHub. If not, I highly recommend you to watch my 1-hour YouTube tutorial on this topic. I also have a comprehensive course on my website if you want to master Git and GitHub. So let's make our first commit. Good. All right, we're done with this step. Let's move on to the next lesson. All right, now we're going to build a navigation bar. So here in the app directory, let's add a new file called navbar.tsx. Now, we're not going to put this into a components directory because, as I explained in the first part of the course, in Next.js 13 with the new app router, we don't have to put all our components into a components directory. Instead, we can co-locate our components with the pages or layouts where they are used. In this case, our navigation bar is not a reusable component. The only place where we need it is in our layout. So I put it right next to our layout. Now, let's create a new component. So we type RAFCE. This is one of the shortcuts that come with the ES7 extension that we installed at the beginning of the course. Let's press enter. So here we have a navigation bar. Now let's change the div element to nav so it's more semantic. Now in this navigation bar, first we want to have our logo. So we wrap it with a link component that is defined in the next/link package. When we click on the logo, we should go to the home page. So we set href to the root. For now, I don't want to add a logo, so I just want to type logo. Now, right after that, we want to add our navigation links. So we add an unordered list. Inside this, we want to have two list items. So li times 2 tab, beautiful. Now, once again, we're going to use the link component. Our first link is going to be our dashboard. So let's set href to the root as well. And our second link is going to be the issues page. So here we set href to /issues. Now, before going further, let's add our navigation bar to our layout. So we go to our layout file and add our nav bar inside the body element. So nav bar. Now, I would prefer to wrap our children, which is going to be a page inside the main element. That makes our pages more semantic. Good. Back in the browser, here's what we get. So we have the logo followed by dashboard and issues. Now we want to lay these out horizontally. So back to our nav bar, we have to make this nav element a flex container. So we set class name to flex. Now our logo and list items are laid out horizontally, and that means when we have a flex container, our direct children are laid out horizontally. In this case, the logo and the UL element. But inside the UL element, we don't have a flex container, and that is why the dashboard and issues are laid out vertically. So to lay these out horizontally as well, we should apply the flex class on the UL element. Good. Now, these items are so close to each other. So to give them some space, we apply another Tailwind class that is space -x followed by a number. In this case, I'm going to go with 6. Here's what we get. So we have some space between the children or our outer flex container. Now we need to apply the same class to our unordered list. So here's our UL. Let's give it space x-6. That looks better. Now let's add a border below our navigation bar. So we give our nav element the class of border-b, that is short for bottom. That's better. Now to separate our navigation bar from the main page content, we should give it a bottom margin. So we add one more class here that is MB-5. I think that looks good. Next, let's give our navigation bar a horizontal padding. So we give it a padding X of, let's say 5. That looks good. Now our navigation bar is too narrow. So to increase the height, we apply another class here, H-14. That looks good, but our items are positioned on the top. So to put them in the center, we apply another class here, items-center. Take a look. That looks good. So we got the basic layout working. Next, we need to replace our logo text with a beautiful icon. And for that, we're going to use the React Icons library. So search for React Icons. You will find this page. To use this library, first we have to install React Icons. So here in the terminal, let's install React-Icons version 4.11.0. Beautiful. Now back to this website. We want to have a bug icon as our logo. So let's search for bug. We have various shapes of bugs in different libraries. I'm going to pick the first one, AI fill bug. Now back to our navbar. We import this class from React-Icons/AI because this component is defined in the AI library. Now let's replace our logo with AI fill bug. Here's what we get. Looks beautiful. Now I want to apply a hover effect on these navigation links. So we want to make the text slightly lighter. And when we hover over these links, we want to make it a little bit darker. As an example, let's apply a few classes on our first navigation link. So we set class name to. The first class is text-zinc-500. This makes our text medium gray. Here's what we get. Now to apply a hover effect, we use the hover selector and change the text color to zinc 800. Now take a look. That looks good. Now I want to apply a transition so the change is smoother. To do that, we add another class here that is transition-colors. Now take a look. All right, the transition is smoother. Beautiful. Now we have to apply the same classes on this other navigation link, and this is repetitive. So let me show you a better way. Instead of defining our navigation links here, we're going to define them in an array. Then we will map that array to a bunch of list items. So let's declare an array called links. Now each element in this array should be an object with two properties, a label, like dashboard, and an href. Let's duplicate this. And our second link should be issues. All right. Now, here we map our links array. We map each link to a link component. So I'm going to grab this piece of code, cut it, and then paste it here. Now, each link should have a key. We set the key to link.href because that value uniquely identifies each link. Now we no longer need these list items, so let's delete them. Also, let me put this on a new line so you can see things clearly. So each link should have a key and a class. This is the only place where we set these classes, so there is no duplication in our code. Next, we set the href prop. And here we have to set the value dynamically. We set it to link.href. And similarly, we should add the label dynamically. So we add link.label. Now, both our navigation links are dark gray. And when we hover over them, they become black. Beautiful. So our navigation bar is in a good shape. Now, before going further, we have to make a commit to our repository. So we go to the source control panel and make a commit and say, build the nav bar. All right, now let's see how we can style the active or the currently selected link in the navigation bar. To do that, first we have to create the issues page. So back to our project. Here in the app folder, let's add a new folder called issues. Then we add our page file. Next, we create a React component and call it issues page. With this, if we click on the issues link, we see the issues page. Beautiful. But we want to highlight the active link in the navigation bar. To do that, we have to go back to our NavBar component. In this component, we have to use one of the hooks that comes with Next.js to get the current path or the current route. That is use path name. Use path name. Now the auto completion is not picking it up, so we have to manually import it on the top. So on the top, we import use path name. Make sure to spell it properly. We import this from next/navigation. Next, we call this hook to get the current path. Now, because in this component, we are using this hook, and this hook is dependent on browser APIs, we have to convert this component to a client component. Because as I told you in part 1, we can only access browser APIs in client components, right? So on the top, we add the use client directive. Now, before going further, let's make sure that our application is working up to this point. So let's do a console log and log the current path to make sure we get the right value. So let's bring up the console. We're currently on the issues page. Lovely. Now, if we go to the dashboard, we see the root path. Okay. So let's remove this log statement. Now down here, where we render our links, we want to apply a class dynamically. If the href of the link that we are rendering equals the current path, instead of textsync 500, we want to render textsync 900, which is darker. So here we have to wrap this string in braces. Next, we need to replace these quotation marks with a backtick so we can add stuff dynamically. So we select the first quotation mark, then we press Command and D on Mac or Control and D on Windows. Now we have selected both these quotation marks. We have multi-cursor editing, so in one go, we can replace both of them with a backtick. Good. Now we press Escape to cancel multi-cursor editing. Now here we add a $sign followed by braces. Inside braces, we type our condition. We say if link.href equals the current path, then we render text zinc 900. Otherwise, we render text zinc 500. So let's grab this class from here and move it inside these quotation marks. Let's test our application. So back in the browser, we're currently on the dashboard and the dashboard link is darker. Now, if we go to the issues page, the issues link becomes darker. Beautiful. So this is a simple way to style the active link in the navigation bar. Now, as our applications get more complex, we might end up with complicated conditions here, and tracking what classes are rendered can be a little bit difficult. In those cases, we can use a very popular package called class names. So bring up the terminal and install class names version 2.3.2. Good. Now, on the top, first we import class names from class names. Now, this is a function that we call and give it an object. In this object, we specify the classes that we want to render and the conditions that they should be rendered. This function will then return a string that contains the classes we want to render. Let me show you how this works. So down here, let's remove everything inside the braces. So here's what we have. Now, here we call class names and give it an object. In this object, we add one or more key value pairs. Our keys should be our CSS classes like text zinc 900, and the values should be either true or false. If we set this to true, this class will always be rendered. Now, in this case, we want to render this class only if link.href equals the current path, right? Now, similarly, we add another key value pair that is text zinc 500. And we want to render this if link.href does not equal current path. Let's add one more, that is hover, text zinc 800, and transition colors. We want to render these classes at all times, so we set this to true. Now look at the result. We no longer have string manipulation, and our code is cleaner. We can easily look at this code and see what classes are rendered under what conditions. Let's test our application one more time to make sure we haven't broken anything. So we go to the dashboard. Dashboard is darker. We go to the issues page. The issues link is darker. Beautiful. So we're done with this step, and now it's time to make a commit to our repository. So here I'm going to say style the active link in the navbar. In this section, we're going to use MySQL for storing our data. In case you don't know, MySQL is a very popular database engine. There are, of course, many other database engines out there like Postgres, SQL Server, MongoDB, and so on. Now, if you prefer a different database engine, that's totally fine, but I would suggest you to use MySQL in this section so you can easily follow the lessons. So head over to mysql.com, go to Downloads. Now, at the bottom of this page, you'll find this link, MySQL Community version, which is absolutely free. Then go to MySQL Community Server. And on this page, download the latest version for your operating system. Now for Mac, keep in mind that we have two DMG files for different CPU architectures. We have one for ARM, the other for x86. So if you're a Mac user, depending on the type of your Mac, you have to find the right DMG file. Once you download this, you will get an installation wizard. Just click through. It's very easy to set up. Just remember, as part of that, you'll be asked to enter a root password. So root is like the admin user for our database engine. So whatever password you use for the root user, keep a note of that because in the next lesson, we're going to come back to it. Okay. Now, this is just the database server or database engine. We also need a tool for viewing our database. Now, MySQL gives you a tool called MySQL Workbench. Again, it's free. I don't like this tool. It's ugly. So in this section, I'll be using a tool called DataGrip from JetBrains.com. I absolutely love this tool, but you have to pay to use it. Having said that, you can try it for free for 30 days. So head over to jetbrains.com/datagrip and download the latest version. All right, now we're going to install Prisma to allow our application to interact with our database. So here in the terminal, let's install Prisma version 5.3.1. Good. Next, we run npx prisma init to initialize Prisma in this project. All right, I told you in part 1 that when we run this command, two things happen. Let's quickly review. First, Prisma creates this Prisma folder, and here we have this Prisma schema file. In this file, first we have to change our provider from Postgres to MySQL. Or if you prefer to use Postgres or any other database engines, that's totally fine. Just make sure that you have set the right provider here. Next, we need to update our database URL, which is an environment variable stored in this env file in the root of the project. So let's go here. First, we change the protocol to MySQL. Then we change the root username. In MySQL, that is root. Next, we set our password after the colon. Then we change the port. For MySQL, we have to use 3306. Then we change our database name to issue-tracker or whatever you prefer. Now, we don't need this query parameter. Let's remove it. We're done with setting up Prisma. So let's make a commit and move on to the next step. So set up Prisma. All right, to store issues in our database, first we have to create a Prisma model. So we go to our Prisma schema file and define a new model called issue. As a reminder, make sure to use the Pascal naming convention so we capitalize the first letter of each word. And also make sure to use singular names, so we don't want to call this model issues, just a singular name like issue. Now our issue is going to have various fields or properties. At this point, we want to add only the absolute essential ones. So right now, we are not going to worry about assigning issues to users, and that means we are not going to create a relationship between the issue model and the user model, okay? So we're going to add the core fields or properties. What are those? Well, every issue needs an ID. The type of ID should be an integer. Now here we use the ID attribute to specify that this is an ID column. We use the default attribute to give it a default value. Here we use the auto increment function. So every time a record is inserted into our table, our database engine automatically assigns an ID to that record. Next, we add the title field. This has to be a string. Now, when we use MySQL, the type of the related column in our database is going to be varchar of 191. Now, in case you are not familiar with MySQL or databases in general, varchar means variable character. So varchar of 191 means we can store string values up to 191 characters in these columns. Now 191 is kind of a weird value. So here I want to override the default convention and say I want to store a string up to 255 characters. To do that, we use the db attribute to specify the type of underlying column in our database. Here we are going to use varchar of 255. Next, we add the description field. This also has to be a string. Now, again, the type of this column is going to be varchar of 191, but we want to have really long descriptions. So for that, we use db.text. Now, every issue has to have a status, and the status can be one of three values: open, in progress, and closed. We can use an enum to represent that. So here we define an enum called status. An enum is a set of constant values. So here we're going to add three values: open, in progress, and closed. And by convention, we use all capital letters. So each value on a separate line. And here we don't need to separate them using a comma. Just remember that enums are supported in MySQL, but not necessarily in all database engines. So if you use a different provider, look at the Prisma documentation to make sure that enums are supported. So here we add the status field and set the type to status. Here we can give it a default value of, if we press Control and space, we can see all the possible values. So we set it to open. Now we want to know when each issue is created. The next field we need is created at. This has to be a date time. And we give it a default value of, here we use the now function. So every time a record is inserted into the issue table, the current date time is inserted into this column. We need a similar field that is updated at. This also has to be a date time. Now for the value, we use a different attribute called updated at. With this, every time an issue record is updated, the database engine automatically updates the value of this column. Okay, so here's our issue model. Now let's reformat our code. So here in the terminal, we run npx prisma format. Here's the end result. It's beautiful. The next step is to create and apply a migration. So back in the terminal, we run npx prisma migrate dev. Let's give it a name like initial migration. Or we can be more specific and say create issue. Good. So as you know, when we create a migration, Prisma creates this migrations folder. And for each migration, it creates a subfolder that has the timestamp and the name of the migration. In this folder, we have a migration file. And here we have SQL instructions for creating or updating our database schema to match our models. For example, here we have an instruction for creating a table called issue with these columns. All right, now let's make sure that our database is migrated properly. So I'm going to use Data Grip. You can also use Workbench. In Data Grip, we create a new project. Let's call it Issue Tracker. Now, in this project, we go to Database Explorer. We add a new data source. Here we select MySQL. In this window, we make sure that our host is localhost and the port is 3306. We set the username and the password of the root user. And next, we set the database to issue-tracker or whatever you used earlier. Now down here, let me resize the window. Look, there is a link that says we should update the driver. You might have a different link that says install missing driver files. So make sure to either install or update the driver. Good. So let's click test connection. All right, the connection is successful. Beautiful. Now click on OK. Let's expand our database. So here's our issue tracker database. In this database, we have two tables. Prisma migrations that keeps track of all the migrations we have run so far, and the issue table where we store our issues. So we're done with this step, and now it's time to make a commit to our repository. So here I'm going to say create the issue model. All right, we have a model. Now to store issues, we have to create an API that clients can call. So here in the app folder, let's add a new folder called API. Inside the API folder, we add a new folder called issues. And here we add our route file. In this route file, we export a function called post that takes a request object of type next request. Now here first we call request.json. This returns a promise, so we await it to get the body of the request. And of course, we have to make this function async. Nothing new so far. We covered all of this in part 1. So if you're not sure what I'm doing, you have to go back and start from part 1. Now that we have the request body, before we create an issue, first we have to validate our request to make sure it doesn't have bad data. Now for data validation, we use Zod. So back in the terminal, let's install Zod version 3.22.2. Beautiful. Now back to our route file. On the top, first we import Z from Zod. Next we call Z.object and give it an object that defines the shape of the object and the body of our request. So let's quickly go back to our Prisma schema file. Look, in this issue model, we only need values for the title and description because all the other fields have a default value. The ID is automatically generated by the database, and here we have assigned a default value to these other fields. So we only need the title and description and the body of the request. So back to our route file. Here we have two properties. Title, this has to be a string with a minimum of 1 character and a maximum of 255 characters. Similarly, we add description. This also has to be a string with a minimum of 1 character. Now, this returns a schema. We store it here. Now, in more complex applications, we are going to have different schemas for different operations. So in those situations, we can be more specific in terms of naming here. For example, we can call this create issue schema. Okay. Now that we have this schema, we can use it to validate the body of the request. So here we call create issue schema that save parse and give it the body object. Now this returns an object. We call it validation. Next we check. If validation is not successful, we return a next response. And here we include validation.error.errors. Now, for the status, what code should we use? 400. That means bad request, meaning the client sent invalid data. Otherwise, If the request is valid, we should store this issue in our database. To do that, we have to import Prisma client. Now, in part 1, I explained that we should have a single instance of the Prisma client, and I explained the proper way to create that single instance. So back to our browser, let's search for Next.js Prisma client. You will find this page, best practice for instantiating Prisma client with Next.js. On this page, we have sample code for creating an instance of Prisma client. We're going to copy all this code. Now, back to our project. We go to our Prisma folder. Here we add a new file called client.ts and paste all that code here. Now, if this looks complicated, don't worry about it. You never have to touch it. You never have to maintain it. All this code is doing is creating a single instance of Prisma client. It ensures that we don't have multiple instances running. Okay? So we have a Prisma client. Now, back to our route file. On the top, we import Prisma from @ which represents the root of our project, /Prisma/client. With this Prisma client, we can insert a new issue in our database. So here we call Prisma.issue.create. We pass an object. Here we set data to an object with two properties, title, which we set to body.title, and description, which we set to body.description. Okay, now we await the call to get the new issue. And finally, we return this to the client. So we return a next response with the new issue. Now, optionally, we can set the status to 201, which means an object was created. So we're done with the API. Now let's test it. So let's bring up Postman and create a new request here. We're going to send a post request to localhost port 3000/API/issues. Here on the body tab, we select raw and then JSON. Let's pass a JSON object. First, I'm going to set title to an empty string and leave out the description property. Let's make sure our data validation logic is working. So send, take a look. All right, we have a bad request, and here in the response, we have our error object. Beautiful. So now let's send a valid issue. I'm going to set the title to first issue and description to description of the first issue. Send. Now let's look at the response. The status is 201, and here's the issue that was created. As you can see, the ID was generated by the database and it's set to 1. Now we can go back to data grip and refresh this table to make sure that our issue is stored in this table. Beautiful. So let's make a commit and say, build an API for creating issues. All right, to build the new issue page, we're going to use Radix UI, which is a very popular component library. So head over to radix-ui.com. Now, Radix comes in two flavors. We have Radix themes, which are beautifully styled components, like the components you see here. We have input fields, buttons, avatars, and so on. But we also have Radix primitives, which are a bunch of unstyled components. These components only have behavior, so we have to style it ourselves. In this course, we're going to use Radix themes. So back to this page, let's click Get Started. Now to get started, there are a number of steps we have to follow. First, we have to install Radix themes. So let's copy this line and paste it in the terminal. All right. Now let me show you the version that is installed here. So let's go to package.json and search for Radix. The version that I'm using is 1.1.2. All right. The second step is to import Radix CSS file in our root layout. So let's copy this line. Now we go to our root layout and import this style sheet on the top. Now, the last step is to wrap our entire application inside the theme component that comes with Radix UI. So back in our layout file, here we import the theme component from Radix UI/themes. Next, we wrap everything inside the body element with our theme component, like this. Now, to verify that we have set up everything properly, let's go to our issues page. So issues/page, and add a button here. So on the top, we import the button component from Radix UI/themes. Now let's add a button here and set the label to new issue. All right, here's what we get. So Radix UI is set up properly. Now, before we create the new issue page, let's make a commit and finish this step. So set up Radix UI. All right, now we're going to build the new issue page. In this lesson, our focus is entirely on the look and feel of this page, so we're not going to worry about submitting the form or handling validation errors. We just want to build a page that has 2 input fields, okay? So let's go back to the documentation of Radix UI. Let's click on this navigation menu. Look, here we have various components for creating layouts like box, flex, grid, and so on. We also have various components for creating topography like text, heading, and so on. And down here, we have more full-fledged components. For example, we have a component called text field. So here's an example. We start with text field.root. Now, if you want to have an icon like this magnifying glass, inside the root component, we add a slot, and inside the slot, we add our icon. Right after the slot, we add a text field.input component. In this case, we don't care about an icon, so all we need is a root and an input component. So back to our project. Here in the issues folder, let's add a new folder called new. Here we add our page file. Next, we create a React component called new issue page. On this page, we need a text field component. Now, if auto-completion doesn't work properly for you, just restart VS Code and the problem should go away. So we add text field.root, and inside that, we add text field.input. Let's give it a placeholder like title. Now, to add a link to this page, we go to the issues page. So issues/page. Earlier, we added this button. Now, inside the button, we're going to add a link component. So we use the link component that is defined in next/link package. Note that there is another link component defined in Radix UI/themes. We don't want this one. We should pick the one in the next package. So we add a link, and here we set href to /issues/new, and the label to new issue. Now, back in the browser, let's click this button. All right, we get an error saying cannot access text field.root on the server. So because we're building a form and building forms requires user interaction, the text field component cannot be rendered on the server. So we have to make the new issue page a client component. So on the top, we add use client. Now, refresh. All right, here's what we get. By default, our text input field takes the entire width of the page. So to narrow it, we can apply a max width to its container. So here's the containing div. We set class name to max width x large. With that, here's what we get that looks better. Now, this input field is so close to the left side of the screen, so we should apply a padding to our main element. So let's go back to our layout file. Here's our main element. Here we set class name to p-5, and with that, we get a bit of padding here. That looks better. So here's our text field. Right after that, we want to add a text area. Again, if you look at the documentation, you will find the text area component. It's right here. It's very easy to use. This one is simpler. We just add text area and give it a placeholder. So back to our page, right after our text field, we add a text area and give it a placeholder description. Here's what we get. Now, these two input fields are so close to each other. To solve this problem, we apply some vertical spacing. So back to this page, we apply another class here called space-y-3. That looks better. Now, finally, we need to add the submit button. So right after our text area, we add a button component that is defined in Radix UI. And here we set the label to submit new issue. All right, here's what we get. So we're done with this step. And now it's time to make a commit to our repository. So here we say, build the new issue page. One of the great things about Radix UI is that it allows us to easily customize our theme. Let me show you how to do this. So let's go back to our layout file. All right, look, this is where we're using the theme component. Inside this tag, right after the main element, we add the theme panel component from Radix UI. Now, we get this panel for customizing our theme. So as you can see, our accent color is set to blue. That is why our button is blue. We can easily change it here and preview the changes. In this lesson, I'm going to select violet. Now we can also change the light or dark mode. Now, for some reason, this is not currently working. It's a little bit flaky, but don't worry about it. Here we can also change the radius of our components. For example, currently the radius is medium. We can set it to none. Now we have sharp corners here, or we can set it to full. We have round corners. I'm going to select medium. Now, down the bottom, we can copy this theme. Now, back to our layout. Let's paste it here. Look, we get this theme tag with two props, appearance and accent color. So let's remove this other tag. And this is how we can customize our theme. We're done with the theme panel. Let's remove it from here. Now, there's one more thing I want to show you in this lesson. So right now, we are not using the inter font that is used in Next.js projects by default. So to refresh your memory, look here in this layout file, we are using the inter font from next/font/Google. Now, when using Radix UI, the inter font is not used by default because we have to do a bit of configuration to make it work. To verify that the inter font is used, let's select one of these links and inspect it. All right, here in DevTools, let's select the Computer tab and look at the font family. So font family is set to Apple System. This is the default system font, so it's not inter. Now, how can we solve this problem? Back to the documentation of Radix UI. Here, we have a page for typography. Here, under theme, let's go to typography and search for next. So here are the instructions for using the inter font with Radix UI. So we have to go to our layout file and assign a custom CSS variable to this font. So we copy this line and paste it here. So here's where we create an inter font. In this object, we set the variable to a custom CSS property. In the first part of this course, I explained how this feature works. So back to this page. Next, we need to go to our root layout and set the class name of the HTML element to inter.variable. So by default, that is inter.className. We have to change it to inter.variable. So we use that custom CSS property. So this is our root layout. Now the font is applied to our body element. So we set the class name to inter.variable. Next, we should create a custom CSS file for overriding the styles of Radix UI. So we're going to create a file called theme-config.css. And in that file, we'll add this style. So here in the app folder, we add a new file called theme-config.css. Now, let's copy this piece of code and paste it here. And finally, we have to import this file in our root layout. So let's go back to our root layout on the top. So first we import the default styles of Radix UI. Then we import our custom theme file. That is /theme-config.css. And finally, we add any global styles. Now, back in the browser, let's make sure that the inter font is loaded. So let's select this element and inspect it. Now here on the computer tab, look at the font family. Now we're using the inter font. So we're done with this step, and now it's time to make another commit. So here I'm going to say customize Radix UI theme. Hey guys, Mosh here. I hope you're enjoying what you're seeing so far. Now, after you've finished this tutorial, if you're ready to take your skills to the next level, I highly recommend you to look at my ultimate Next.js series. The full series contains 2 courses and is 12 hours long. The first part, which is 5 hours, teaches you everything you need to know to build full-stack applications with Next.js. The second part, which is 7 hours, is where we build and deploy the complete issue tracker project. So by the end, you will have a complete project that you can show to your friends or potential employers and get your dream job. The course comes with a certificate of completion and a 30-day money-back guarantee, so you can try it risk-free. If you're not happy, just contact us and ask for a refund. So if you're serious about learning Next.js and want to use it professionally, I highly encourage you to enroll in the full course after you finish this tutorial. Again, in case you're interested, the link is below this video. Alright, now let's see how we can replace this text area component with a Markdown editor. For that, we're going to use a component called React Simple MD Editor. So search for this, you will find this page on NPM. This is a React component wrapper around EasyMDE, which is a popular JavaScript library for rendering a Markdown editor. So let's look at the installation instructions. It's very easy. First, we have to install these 2 packages, React Simple MD Editor and EasyMDE. So let's copy this line and paste it in the terminal. Good. Now to use this component, we have to import the Simple MD component and a corresponding CSS file. So let's copy these 2 lines. Now we go back to our new issue page and paste these import statements on the top. Now, here we don't need React, so let's remove it. Also, we no longer need the text area component. Now, all we have to do is replace this component with Simple MD. With that, we get this beautiful Markdown editor. Now, this is fully customizable. We can change the buttons on the toolbar. Here we also have spell checking by default. So if you type something that is not a valid English word, we get this red highlight. Now, in this course, I'm not going to talk about customizing this editor. It's really outside the scope and it doesn't value every student of this course. So I leave it up to you to read the documentation and figure out how to customize this if you want to. All right, we're done with this step and now it's time to make another commit. So here I'm going to say add a Markdown editor. All right, our form is ready. Now it's time to handle the form submission. And to do that, we're going to use a very popular library called React Hook Form. Chances are you're familiar with this library, but if not, this library makes it incredibly easy to handle form submission, track changes in our form, and display validation errors. So let's go to the terminal and install React-Hook-Form version 7.46.1. Good. Now we go to our new issue page and on the top, we import a hook called useForm from React Hook Form. Next, we define an interface that defines the shape of our form. It specifies what fields we have and what are their types. So we define an interface. We can call it issue form. Here we add 2 properties, title of type string and description of type string. Next, we call this hook in our component. So here we call use form. And in angle brackets, we specify the shape of our form. In this case, issue form. We call this function and get an object. Now we destructure that object to grab the register function. Using this function, we can register our input fields with React hook form so it can keep track of them. Let me show you how this function works. So let's do a console.log and call register and give it a label like title. Now, back to the browser. Let's bring up the console. Look, we get an object with 4 properties: name, which is title, as well as onChange, onBlur, and ref. So these are the props that we should apply to an input field so React hook form can keep track of changes in that input field. So let's remove console.log from here and call the register function right here, where we use this input component. So inside braces, we call the register function and register this field with React hook form. Now you saw that the register function returns an object with 4 properties. So here we have to use the spread operator so we can add those properties as props to this component. Now, we cannot use the same technique with the simple MDE component because it doesn't support additional props using the spread operator. So if we add braces here and register this as the description field, look, we get a compile time error. To solve this issue, we have to use the controller component in React hook form. So on the top, in addition to the use form hook, we also import the controller component. Now, let's remove these braces from here. So instead of directly rendering this simple MDE component, we have to render a controller component. Now here we have to set a few props. The first one is name, which we set to description. The second one is control, and we set this to the control object that we can get from this hook. So while destructuring this object, we also pick the control property. Now we use that right here. And finally, here we set the render prop to a function for rendering an input field. So we pass a function here, and this is where we render a simple MDE editor. So let's paste it here. Now the final step. We give this function an argument and destructure it to grab the field property. Now this field has the same properties that you saw earlier, like onBlur, onChange, and so on. So this is where we add braces to spread the field object. Okay, so we have registered our input fields with React hook form. Now we should handle the form submission. To do that, we have to grab another function from this object that is handle submit. Now we should wrap our input fields with a form. So I'm going to change this div to a form. Here we're going to use multi-cursor editing. So what was the shortcut? Command and D on Mac or Control and D on Windows. Now both tags are selected. Let's change it to a form. Now here we set on submit. Here we call the handle submit function and give it a function that will be called when our form is submitted. So we pass a function, and here we can do a console.log. Now we want to display the data in our form. Data will be an argument in this function. So we grab it here and pass it to console.log. So let me put this on a new line so we can see things clearly. This is how we can handle the submit event. Now let's test our implementation. So back in the browser, I'm going to set the title to bug1 and description to description of bug1. Now let's submit the form, bring up the console. Here is the object that contains the data in our form. All right, now the final step. Instead of logging this data object on the console, we want to send it to our API. To do that, we're going to use Axios. We can also use the fetch function in browsers, But I personally prefer Axios because the syntax is kind of easier to use. But if you prefer to use fetch, that's totally fine. So let's bring up the terminal and install Axios version 1.5.0. Now, on the top, we import Axios from Axios. Now back to our submit handler. Instead of logging the data on the console, we call axios.post. As the URL, we pass /API/issues. And here we pass our data object. Now this returns a promise, so we have to await it and make this function async. Now finally, we want to redirect the user to the issues page. To do that, we have to use the router hook in Next.js. So here we call use router. Now, I explained this before. We have two router hooks. One is defined in next/router. The other is defined in next/navigation. Make sure to use the second one because this is the one that works with the app router. So we call this and get our router object. And finally, after this issue is saved, we call router.push and send the user to the issues page. Let's test our implementation. So one more time, let's fill out this form, description of bug 1, and send this to the backend. All right, we got an error saying navigator is not defined. This is typically what happens when we use the wrong router hook. In this case, I haven't made a mistake, so this could be a temporary issue. I'm going to restart the web server and see if that solves the problem. All right, now let's refresh this page as well. So let's fill out this form one more time and submit it. All right, we are redirected to the issues page. Now let's go to our database and make sure this issue is properly saved. There you go. We have two instances of this bug because previously, even though we got an error with the navigator object, the bug was actually saved in our database. All right, we're done with this step. So let's make another commit and say handle form submission. Our code doesn't currently have error handling. So the next thing we want to do is to handle potential errors and provide feedback to the user if something goes wrong. To do that, we have to wrap these two lines inside a try-catch block. So here we add a try-catch block. Select this item from auto-completion. When we have this square box, that means this is a code snippet. So enter. Now we have this snippet. Press escape. Now we grab these two lines and move them up like this. Now, if you don't know how to do this, let me show you the shortcut. So on the top, go to the selection menu and look at the shortcut for these commands, move line up or down. On Mac, it's Option with up and down. I think on Windows, it should be Alt. So we put these two lines inside the try block. Now, let's just log the error that we get in the catch block. Now, back in the browser, let's submit the form and see what we get in the console. All right, we get an Axios error object. Now look at the properties. Here we have the code that is set to error bad request. The message says request failed with status code of 400. Now, because this is an error that we anticipated in our API, here we have a response. So in the response object, in the data property, we have the error messages that are generated by Zod. So let's go back to our API. We go to our route file. Take a look. If the validation is not successful, we are returning these validation errors. Now, if you don't like this structure, if you think this is too complicated, here we can call the format method. And with this, we'll get a simpler structure. So let's refresh and submit the form again. Take a look. Once again, we go to response and data. Now, for each field in our form, we have a property like title and description. We also have a generic error property for any validation errors that are not specific to one of these fields. Now, for each of these fields, we have a property called underline errors, and here we have a friendly error message, like string must contain at least one character. Now we can also customize these error messages. To do that, we have to go back to our schema. So over here, as the second argument to the min method, we can provide a custom error message like title is required. We can do the same with our description field. So description is required. Now let's submit the form one more time and look at our error object, response, data. Let's look at the title property. There you go. So we have title is required. Now, in this case, we don't really care about these error messages because we shouldn't be able to post the form if the form is invalid. So in the next lesson, we're going to implement client-side validation and show errors to the user if the form is invalid. But this technique is useful in situations where we have to rely on the backend to validate the data. For example, if you want to build a registration form, we want to make sure that the user selects a unique username. That's not something that we can validate on the client. We have to rely on the backend, right? In those cases, this is how we can read the error messages returned from the server, and then we can show that error to the user. So back to our error handling code. In this case, we don't want to log the error on the console. Instead, we want to show a generic error message for unexpected errors. And to do that, first we have to declare a state variable for holding the error. So here we use the state hook. We initialize our variable to an empty string. Then we add error and set error. And in our catch block, we simply call set error and give it a generic error message, like an unexpected error occurred. Now, we want to show the error message right above the form. To do that, we're going to use one of the components in Radix UI. So let's look at our components here. It is called, where is it? Callout. So this is how a callout looks like. We can also change the color to red. In terms of the structure, we start with callout.root. If you want to add an icon, then we add a callout icon. And otherwise, after that, we add callout.text, similar to how we use the text field component, right? So right above this form, we want to add a callout. To do that, first we have to wrap this inside a fragment or inside a div. I'm going to use a div because later we're going to apply a couple of classes here. So let's wrap the form inside a div. Now, right above the form, we add callout.root. And we want to render this only if we have an error. So if we have an error, then we render this callout. Now, inside the callout, we should add callout.text. And this is where we render our error message. Now, to change the color to red, we set the color prop to red. Now, save the changes. Back to the form. Let's submit it again. Now we have this callout on the top. But the width of the callout is not the same as the width of our form. So we have to move this max width class to the containing div. So let's grab it from here and add it here. Good. Now let's submit the form one more time. All right, that looks better. I want to add a margin below this error message. So let's give this callout a class of MB-5. All right, let's try it one more time. That looks good. We're done with this step. Now, let's make a commit and say handle errors. All right, now let's implement client-side validation. So let's go to our route file. So earlier we defined this schema for validating the object that is sent with our request. Now, wouldn't that be nice if we could reuse the same schema for validating our form? We can certainly do that. Let me show you how to do it. First, we have to grab this schema and put it into a separate module so we can reuse it in two places, in our API here and also in our form. To do that, I'm not going to grab this code and cut it and paste it somewhere else, because with that, our project will break. We'll have to come back here and explicitly import this schema from that other module. A better way is to use the refactoring commands in VS Code. So we put the cursor right here, then right click and go to refactor. Now let's move this to a new file. With that, as you can see, VS Code put our schema into this module and automatically imported it on the top. We didn't have to manually do this, right? Now, back to our API folder. So this is where our schema exists, right next to our route file. Now we should take it outside of this folder and put it somewhere more general, because we want to use this in our form as well. So let's grab it and move it to the app folder. And also, I would prefer to rename this file to something more general, like validation schemas. So in the future, we can add all our validation schemas in this file. All right, now to use this in our form, first we have to install a package. So bring up the terminal window and install @hookform/resolvers version 3.3.1. This package allows React Hook Form to integrate with various data validation libraries like Zod. So let's install it. Good. Now let's go back to our new issue page. On the top, we have to import Zod resolver from hookform/resolvers/Zod. Now, when calling the useForm hook, here we pass a configuration object and set the resolver to Zod resolver. And here we pass our Zod schema, that is create issue schema. So now this schema is imported on the top from our app folder. So this is how we can integrate React Hook Forms with Zod. Now look at this interface we have defined here. It kind of looks redundant because here we are defining two properties that already exist in our schema. In the future, if we decide to extend this form and add a new property, we have to add it in two places, in this validation schema and also in this interface. Wouldn't that be nicer if we could generate this interface based on our schema? Let me show you how to do that. So first we import Z from Zod. Next, we remove this interface. And here we call z.infer. In angle brackets, we type of, and here we pass our schema, create issue schema. This returns a type, so we store it in the type object and call it issue form. So now we are letting Zod infer this type based on this schema, okay? All right, next. So we have integrated React Hook Form with Zod. Now to display validation errors, here we have to grab the form state object. This object represents everything we need to know about our form. So we can destructure it right here. Now let's press Ctrl and space to look at various properties. So we have errors. We have is dirty. This is useful if you want to know the form is changed. We also have is submitted, is valid, and so on. Is valid is useful if you want to disable the submit button if the form is not valid. Now, in this case, we only care about this property, errors. Now, we want to render an error message after each field. So this is where we have the title field. Right after that, here we check if errors.title is truthy, that means we have an error for the title field. So here we render a paragraph, or we can use the text component in Radix UI. Make sure to import it from Radix UI. And this is for consistency. So in this file, we're using Radix UI components as much as possible. Here we can set the color of text to red. And with this, we can make sure that all our validation errors have the same color. And right here, we render errors.title.message. Now we need to add an error message for the description field as well. So right after this controller, we check if errors.description is truthy, then we add a text component. We set the color to red. And here we render errors.description.message. That's all we had to do. Now, back in the browser, let's submit the form. We get our validation messages, beautiful. Now here we have a bit of styling issue because the text component is not a block level element. So let's right click it and inspect it. Look, it's a span. To solve this problem, here we can set the as prop to the type of element that should be rendered for this error message. We're going to use a paragraph. We need to do the same for our description error. Now let's submit the form one more time. All right, that looks good. We're done with this step. So let's make another commit and say implement client-side validation. Look at the way we are rendering errors on this page. Do you see a problem here? Here's a problem. Every time we want to render an error, we have to remember to set these two props so our errors look consistent. This is where we can extract this markup and put it into a separate reusable component. So here in our project, in the app folder, let's add a new folder called components. Here we add a new file. We call it ErrorMessage. Now let's create a React component. Now, typically here we define an interface called props. We give it a property called children of type React node. Then we add props here. Now we can destructure this to grab children. But this is kind of unnecessary because in React, we have a type that defines this shape. So instead of explicitly defining this interface every time, here we can use props with children. This type is defined in the React module. So if we control-click this, look, this is a type that defines an object with this shape, children. Okay? So we no longer need this interface. Good. Now here, we return a text component that is defined in Radix UI. We set those two props. So we set color to red and as to P. And then here we render children. Now we have a single place where we define the look and feel of our errors. And with this, we can get rid of this duplication in our code. So we replace this text component with our custom error message. Now we can take this to the next level. Instead of checking if there is an error for this property every single time, we can move this responsibility inside the error message component. So here we can check if children is falsy, then we return null, so nothing is rendered. Otherwise, we return a text component. And with that, we can simplify our code. We can get rid of this condition. Now here we get a compilation error because title may be undefined. To solve this, we use optional chaining. So here's the end result. It's much nicer, much cleaner, and we don't have any kind of duplication here. Let's apply the same technique to the description error. So we remove the braces and replace the text component with an error message. And here we use optional chaining. Let's test our application to make sure we haven't broken anything. So I'm going to submit the form. Beautiful. So we're done with this step. And now it's time to make another commit. Extract the error message component. Now, to improve user experience, we want to show a spinner in the button when submitting the form. To do that, search for Tailwind Elements Spinner. On this page, you can see various examples of showing spinners using Tailwind. So here's a basic example. We can also change the color. We can use a different effect. We have all sorts of spinners. So let's look at the basic example. Look at the code. So we're going to grab this markup and put it into a reusable component. So let's copy it here. Now back to our project. Here in the components folder, let's add a new file called spinner. We create a React component and then paste all that markup. Now, we have two class attributes that we should rename to class name. One way is to put the cursor here, press Command and D on Mac or Control and D on Windows to select the next occurrence. But let me show you another technique. If we have many instances that we want to rename in one go, we don't want to keep pressing Command and D. We can select all of them using a special shortcut. So on the top, under the selection menu, look at the shortcut for select all occurrences. On Mac, it's Shift, Command, and L. I guess on Windows, it's Shift, Control, and L. So let's press Escape. I'm going to press Shift, Command, and L. Now, all instances of the class keyword are selected. So let's rename this to class name. Save the changes. Now to test this, let's go to our new issue page and put a spinner inside this button. All right, here's what we get. Our spinner is a little bit too large. So to make it smaller, let's go back to our spinner component and change the height and the width to 4. Now we can take this to the next level and give it a size prop so we can render spinners at different sizes. But at this point, that is over-engineering because we don't have that requirement. That's one of the traps that a lot of software developers fall into. They start predicting all kinds of what-if scenarios that may never happen. So don't over-engineer your solutions. Instead, focus on existing problems as opposed to problems that may never happen in the future. So we change the size to 4. Now, here's what we get. Our spinner is a little bit too thick for this size. So to make it thinner, we change the size of the border from 4 to 2. All right, I think that looks good. Now we want to show this only when the form is submitted. To do that, we go back to our new issue page and declare a state variable. We initialize it to false and call it is submitting. Now, in our try block, before we call the backend, first we set submitting to true. And in our catch block, if something goes wrong, we reset it so the spinner doesn't stay there. Now, finally, in our button, we render the spinner only if the form is submitting. So is submitting. If it's truthy, then we render a spinner. Now, it's also a good practice to disable the button to prevent the user from submitting the form twice. This is especially important when building applications that deal with money. So let's set disable to is submitting. All right, here's what we have. Let's test our application. So once again, if we submit the form without any values, we get our validation errors. Beautiful. Now let's add a bug here. Description of bug 3. Submit. Beautiful. We're done with this step, and now it's time to make another commit. Add a spinner. We're almost done with implementing our first feature. So now let's spend a few minutes and talk about better ways to organize our code. Now, the first thing I'm going to talk about is this inline function in this component. So some people argue that we shouldn't use inline functions in the middle of our markup because they make things unnecessarily complicated. Now, there are other people who like inline functions, they prefer inline functions, and they argue that inline functions are easier to understand because they don't have to jump back and forth between different parts of the code to see what is going on. So this is one of those areas where different people have different opinions. There's really no right or wrong here. In my opinion, inline functions are not necessarily evil. If there are 1 or 2 lines, it's better to keep them inline. But otherwise, if they get more complex, it's better to move them outside and separate them from our markup. In this case, our inline function has 7 lines of code, so I prefer to move this logic outside of this markup. So let's declare a constant called onSubmit, and we set it to this piece of code. Like this. So now the logic for submitting the form is completely separated from our markup. We just have to remember to add onSubmit here, With this, our markup is completely separated from our logic. So that was good. Now, there is another issue we want to talk about here, and that is this line of code. Some people argue that using Axios in the middle of a component violates the separation of concerns principle. What is separation of concerns? Well, it's one of the old computer science principles that says we should separate a program into distinct modules, each having a separate concern. If concerns are well separated, there are more opportunities for code reuse. So people who argue that we shouldn't use Axios or make HTTP calls inside a component suggest that we should move this logic into a separate function outside of this module and then call that function here. For example, we could have a function like create issue that takes the data. So in that function, we'll have the code for making the HTTP call. I have done this a lot in the past, but over time, my views have changed. In this application, I don't see any value in moving this logic inside a separate function. That is just unnecessary abstraction. Because realistically, in this application, this is the only place where we need to create an issue. So we're not going to reuse this function in other parts of our application. So the promise of reusing this piece of logic doesn't apply here. But in other applications, making HTTP calls might be more complicated. For example, sometimes when calling third-party APIs, we have to include certain HTTP headers in each request. In those cases, we don't want to throw all that complexity inside our components. So it's better to move the logic for making HTTP calls into separate modules. So here's what I want you to take away. Software engineering is not black and white. There is no one size fits all. So if someone says, this is the best practice, you should always do things this way, don't listen to that person. Every project is different. Every application has different requirements. Don't take someone else's solution and apply it as silver bullet in all your projects. So in this application, at this point, I don't see a reason for moving this logic for making HTTP call into a separate module. So let's remove this comment. We're done with this step. So let's make one more commit. Here I'm going to say refactor move inline function. Congratulations on reaching this point and creating something awesome along with me. Now, as I said before, this tutorial is only the beginning. So I invite you to join me in my ultimate Next.js series. This series contains 2 courses. The first part covers everything about Next.js, and part 2 is where we build and deploy this issue tracker project. Now, because you have stuck with me till now, I'm offering you a special discount, but this is only available to the first 100 people. So click the link below and let's continue this journey and build the issue tracker project together.